Hi students, welcome to chemistry sessions. So in this class we are going to discuss the objective type questions that is a part of the new CBSE exam pattern, and that too for the chapter Aldehydes Ketones and Carboxylic acid, a very important chapter, holds a lot of weightage in the entrance exams as well as in the CBSE. So why I am talking about the entrance exams, because again this kind of pattern which is introduced by CBSE is just to give you an idea, just to give you a practice of how you are going to perform in your entrance exams. Yes, that is a positive thing. Okay, so let's move on to the first question. Obviously we are dealing here with the level of CBSE, not the IIT, so don't think of like that. Okay, so very simple reaction which is given over here is Cannizzaro. You know what Cannizzaro reaction is. If you know what kind of compounds give it, you get the question. So Cannizzaro's reaction is not given by. Please be careful about the question, not given by. That means out of 4, 3 are giving the Cannizzaro. What is the condition for Cannizzaro reaction? That those having no alpha hydrogen atoms. Alpha hydrogen atom, what is alpha? See, if this is the concerned carbonyl carbon and the carbon which is adjacent to it, this is the alpha carbon atom, right? And the hydrogens which are attached to it, this is the alpha hydrogens, fine. So the concerned carbon, the adjacent to that is the alpha carbon, adjacent to that is the beta and then gamma and so on. So this is alpha carbon and the hydrogens attached to the alpha carbon is the alpha hydrogens, right? I have to watch out for no alpha hydrogens. That means only the concerned carbon and the adjacent carbon not having any alpha hydrogens. Let's see. In the very first one, so this is the concerned carbonyl carbon, right? COH, we can expand it like that. And the adjacent carbon is having this group, is having this group, and having a CH3, no hydrogen present, so this would give, fine. No, this is not my answer. We have to find out the one which is not giving. Okay, next one is benzaldehyde, carbon concerned carbon, adjacent to it, again this carbon is involved with this group and these two double bonds and no hydrogen present, right? So again this will also give. HCHO formaldehyde, obviously this will give because this is the concerned carbon and adjacent to it is no carbon, right? So there is no point of alpha hydrogen present in it. It will definitely give Cannizzaro and this will not give, and this is my answer because this is the concerned carbon, adjacent carbon and CH3. So this compound ethanol will not give the Cannizzaro reaction, right? So I hope everybody is clear. That was a very simple and easy question. So in aldehydes and ketones chapter, Cannizzaro reaction and aldol condensation, these two are really very important name reactions. Now the next one, this kind of question also comes up in CBSE subjective ones, right? But here what they have given it in a MCQ format, right? So let's deal with the reaction. First, what is given is, it is given an alkyne and this particular reagent thing, right? And now can you recognize these reagents? What is it? Which kind of a reaction is this? Very important. You know, this is hydration of alkenes, hydration of alkynes, sorry, right? And hydration means I need to provide the water molecule to it. That means OH must be getting attached, right? How? Because of certain amount of acidic nature which is present in the reaction. So due to that, what will happen is a product A will be formed and A will isomerize to give ketone, acetone, right? So a little idea I am getting through this, you know, mechanism is that it has been isomerized into a ketone, and as I told you, hydration will be giving an OH attached onto the molecule. So that means OH getting converted into ketone. What I can suspect is it can be tautomerism. What is tautomerism? It is converting the ene to ol form. Sorry, it is converting the enol form to one form. That is what the tautomerism is. See here, if I have got an alcohol like this, something like this sort, okay. So it rearranges itself and this hydrogen comes up here and this bond comes up this side. So basically the stable product which is formed is ketone, fine. So I have got my A also here, right, as I suspected. But let us just confirm it by the reagents. So what I have given is an alkyne, propyne basically we have got like this, and let's just try to assume that the reaction is happening. Let's just go on to the mechanism. So what will happen is this will shift to this side negative and this is going to be positive. This H positive will shift here, CH2 sort of, and this is positive. Obviously in the medium there will be OH negative ions which will get attached over here, and I get what I suspected, this one. Sort of this kind of a mechanism will be followed. And what compound is it? See here, 1, 2, 3. So I'll be numbering from right hand, from this side CH3 or this side. What do you think? So obviously this will be given, double bond will be given the preference 1, 2 and 3, right? So this will be prop 1-ene 2-ol, right? Let's check out the options. Prop 1-ene 2-ol, but here they are giving me metamerism. I don't think metamerism will do. Prop 1-ene 2-ol, where is it? Geometrical isomerism? No, not at all. Prop 1-ene 2-ol tautomerism, and that is my answer, right? I hope everybody is clear. So that was an interesting question. So this was a mapping question basically, that you have to find out A, B and the products which are getting formed in the reaction. It's interesting. So now question number 3, which of the following compounds is most reactive towards nucleophilic addition reaction? Now in such kind of questions, as they have given is nucleophilic addition, right? Nucleophile must be getting added. So as far as the carbonyls are concerned, always remember this is the carbonyl, right? Delta negative and delta positive polarity is getting created, and onto the carbon atom the nucleophile gets attached. Fine. So you have to remember this, like if I have got OH negative in the vicinity, it will come and get attached onto the carbon. But if there would have been very less positive charge, almost nil positive charge on this carbon, so nucleophile would not be, nucleophilic attack would not be favorable. Fine. So what I have to look for is nucleophilic addition reaction, very much feasibility, okay. So feasibility of the nucleophilic addition will be when this carbon will be having a lot of positive charge onto it. Let's see in which structure it happens. In the first one, delta negative, delta positive, alkyl being the donating group will reduce the positivity of the carbon, not favorable. Now come on to this one, benzaldehyde, delta negative, delta positive. So this is positive, and definitely what will happen is, due to the resonance effect of this benzene, it will get stabilized again. Now here, oh my god, there are 2 alkyl groups instead of 1, again lessening the amount of the positivity of the carbon. And here what do you see? This delta positive, okay, delta negative, fine. Now a big confusion, because in all of the options what do you see is, you see some or the other thing is neutralizing the carbon positive charge. Now my take for this question will be that which carbon will be getting least neutralized, right? So let's check out, as far as alkyls are concerned and the phenyl group is concerned. Out of the phenyl, you know what, there is another property of the phenyl group, right? Here what you see is sp2 hybridized carbon, yes or no? So this sp2 hybridized carbon, instead of these sp3 hybridized, sp2 is much more electronegative also. So you cannot overlook that property of the carbon, right? So due to sp2, I know that out of these 2 options my answer is, but because I have overlooked these, I have ruled out these 2 options because of the sp3 hybridized and donating alkyl groups, much more donating. So what do you see over here is, if I don't consider the concept of resonance, before resonance there is the electronegativity of the carbon, sp2 hybridized. So out of the 2, here I have got an alkyl group which is again lessening the amount of positivity, but here I do not have anything but this, right? So my appropriate option answer will be C, right? I hope everybody has got it. So that was a Really interesting question where we had to apply not just one concept but two to rule out the options. That was interesting. Okay. Now come on to the next one. It's easy, but you have to have a very good knowledge of the reagents, right? The reagent which does not react with, it is not reacting with both acetone and benzaldehyde. Okay. So the names of the compounds which are given, acetone and benzaldehyde, is just given to confuse you. Why? Because one is simple ketone, another is simply the aldehyde, right? So ketone and aldehyde. So we have to just look which one will not react, or if both are reacting or so. Okay. So sodium hydrogen sulfide, NaHSO3, what is it? What kind of a reagent is it? So basically it has polarities Na plus HSO3 negative, that is how it breaks. So since it has got two ions, it will be requiring a polar molecule to get attached, right? And in both of them there is polarity because of the carbonyl group, right? So definitely this is going to react. Phenylhydrazine. You must have learned about phenylhydrazine as the nucleophilic addition reactions which the aldehydes and ketones are capable of, right? So phenylhydrazine, there is no point, it will react with both of them, right? I am not going into the detail of this particular reaction because I am assuming that you have seen my lectures for that. Felling's solution, Felling solution. Now out of toluenes and Fellings, what do you think what will happen? You know, Fellings and toluenes, both of them are very reactive towards the aldehydes but not the ketones, if you remember, right? So what I have got here is that acetone will not react. Yes, and Grignard, obviously aldehydes and ketones, because in Grignard there is a polarity. Yes, delta positive, delta negative, right? Polarity searches for polarity. So the carbonyl group has got it, both aldehyde and ketones are capable of, but not the Fellings one. So what I have done is I have ruled out all the three and I have got my answer as C, right? So Felling solution will be the answer because acetone is not going to react with that, right? Okay. Now, so that was the question, interesting one. Now the next one is the correct order of increasing acidic strength. Now for acidic strength for acid, you have to be very careful because as I told you, I have told you in many lectures that if we need to check out the acidity for a particular compound, right? So what you have to do is just to release the H positive and then see the stability of the remaining anion, right? And you will get your answer. If the anion is very stable, then the molecule will be readily giving out the H positive and being most acidic, right? So that is the funda you have to follow. So what compounds we have given? Let's just first draw the structures of all of them to find out who is most acidic, who is the main culprit. First one is the phenol, next is ethanol, okay. Third one is chloroacetic acid, okay, chloroacetic acid. So you know what acetic acid is? That is also given in the question. And chloroacetic acid, yes. So that means one chlorine is attached onto this carbon, that is what chloroacetic acid is, see, like that. Okay, so these are the four options given, and as I told you, remove the H positive and see the stability. Okay, so first, not even removing the H positive and seeing the stability, what first thing which comes up in my mind is, it is already acid, these are already acids, yes, we write acids in their name. So these will definitely be more acidic than the alcohols, right? So these are the two which will be most acidic, but out of the two, which one is more? Let's see. So what I observe out of the two is common sense that a chlorine is the thing which is attached, which is different in the two things, right? Now chlorine, what is the nature of the chlorine? It is withdrawing group. It is withdrawing the electron density, thereby this H positive will be released very quickly, right? This H positive is released quickly, this is more acidic, and I get out of the two chloroacetic acid the most acidic one. So chloroacetic acid, the most acidic one, increasing strength I have to find out. So this one, I think this should be the option. Let's check. Next is the acetic acid. We have already figured it out. And out of ethanol and phenol, now see here, it's important. Out of ethanol and phenol, if I just try to remove the H positive, I get here C2H5O negative anion, right? And here the phenoxide ion. So as we all know that phenoxide ion is a super fun ion, right? Why? Because it is resonance stabilized, it's very stable, right? So phenol is much more acidic than the normal alkyl alcohol, right? So from here we have got an idea that phenol will be more acidic and the least will be ethanol. And from this particular series we have realized that C is the correct option and not the other options. Fine. So I hope everybody is clear with the concept that how we have to check the acidity. And the typical thing is, whenever we are dealing with alkyl and aryl, here the reasons has to be, your reason has to be very hardcore, okay. Now the last question of this questionnaire is a typical question of assertion reason, right? So CBSE this time has incorporated this kind of a question in your syllabus, in your exam pattern. Why? Because again, firstly, the benefit that you are getting from these type of questions is you will be able to perform such questions in your entrance exams, because mostly around 98% of the students appear for IIT JEE and other entrance exams every year, right? So what happens is, students who are concentrating on CBSE, they are not able to perform much in the IITs, and those who are performing in the entrance exam are not scoring well in the CBSE. So that is the lag which is coming in between the two. So just to bridge that gap, just to give you an idea, CBSE has included such MCQs as well as these assertion type reason questions to give you an idea, to make you well practiced, well knowledgeable about the entrance exams also, right? Okay, so what is basically assertion reason is, assertion means a statement given to you, right? It can be related to your concepts, obviously it is related to your concept, and the reason for that. But obviously the reason can be incorrect. So that is what you have to look for. Assertion, okay, the statement 1, that has to be correct, okay. So just check whether the statement 1 is correct or not, just check its reason is correct or not, or also it can happen that the statement 1 is correct and the reason is correct, but reason is not the correct explanation of that statement. That can also be a thing, right? So for that they have given you 4 options. First one is, if both assertion and reason are correct, right? Both can be correct and reason is the correct explanation of assertion. Good one. Now the next one is, if both assertion reason are correct but the reason is not the correct explanation, right? That can be a possibility. Third can be, if assertion is correct but the reason is incorrect, and if both assertion and reason are incorrect. Also, there can be a different option also herein, that means the reason is correct but the assertion is incorrect. So you have to look for the instructions first. First read out the instructions, then you can proceed further, fine. The question, the type of question remains the same, your knowledge remains the same, and your performing capability, it remains the same, fine. So what is given in this question? Assertion, the pKa of acetic acid is lower than that of the phenol. So what do you mean by this statement? pKa of acetic acid, even if you don't know what pKa is, no need to worry, they are sort of asking you about the acidity, fine. Out of acetic acid and phenol, which one is more acidic? Obviously, which says acid in its name, it's so common sense, that is acetic acid. Obviously the reason is much more different and detailed, but here we can figure it out like that. So acetic acid will be more acidic, so the one which is more acidic has the lower pKa value. Always remember, if something is more acidic will have less pKa value, something is less acidic will be having more pKa value, right? That is how it goes, fine. So what you observe over here is, they are telling you the truth in the statement 1, but Now come on to the reason. Phenoxide ion is more resonance stabilized than acetate ion. Is it so? Let's see. Phenoxide ion, that means what they are saying is after the removal of H positive we get the phenoxide ion, and after the removal of H positive from here we get the acetate ion, like that. Okay, which one is much more resonance stabilized? Let's see. That is how the resonance occurs. Okay, and that is how the resonance occurs. Fine. So you must be knowing what the criteria for charge separation is. Yes or no? More the charge separation, least stable will be the compound. So here the charge separations, what you get in this scenario will be more as compared to the charge separation over here. So out of the two, so basically I could not go by just the resonance structures, but the another concept, which is the charge separation. So in acetate ion the charge separation is much less and it will be more stable and more resonance stabilized as compared to phenoxide ion, which they have given incorrect in the reason. So reason is incorrect, right? So basically the first statement is correct, the reason is completely incorrect. So for that I have got which option? Let's check out. If assertion is correct but the reason is incorrect, and C is the answer for this particular question, right? I hope everybody has got it. So that was all for today, and you can just go through these questions once again, go through the pattern once again, have a look at the sample papers which CBSE has launched on their website, just to give you an idea about how the questions are going to come, right? Still, if you have got any difficulty, I am here to help. Have a nice day.